This investigation was on genetic basis of antibiotic resistance mechanisms, carried out by Sara Najafi, from Department of Biology, Faculty of Basic Sciences, Hamadan Branch, Islamic Azad University. Hamadan, Iran.
Genetic basis of antibiotic resistant mechanisms. AMR is a complex biological phenomenon that bacteria adopt and develop mechanisms to survive against antibiotics and rendering the antibiotic ineffective in killing or inhibiting their growth. This resistance occurs due to various factors, including gen transfer between bacteria, maybe the most important one, genetic mutation, and overuse and misuse of antibiotics. One must say that antibiotic resistance can occur because of somehow natural selection. It means that some susceptible genes of bacteria in their DNA, maybe they are in their reproduction, they are missed, but some resistant genes are remained and then are reproduced rapidly because the reproduction in bacteria is really simply, and after a little time, we can a lot of resistant genes in bacteria. This slide maybe is the most important slide in this presentation. We see a picture here, three ways of transformation in the bacteria. The most, I can say, first one is transformation because it's the easiest one. Here we can change the transfer the genes in the species or in the our favorable bacteria. The other is transduction. That's the base and main working are same with transformation, but the most important one and maybe complex one are related to conjugation. Here is the most important one that we can say here that it's like complex. I can say complex in the bacteria, and in this way, we can, for example, in favorable thing, for example, we wanna alternate or obtain a favorable genes to our suitable sushi. So we can use these working ways to transferring these transferring our genes, and it's also can transfer the genes, but in every time it's not just favorable genes, and resistant bacteria can transfer their resistance in this situation too. So it's not really maybe suitable here in AMR. As everyone nowadays knows, overuse and misuse of antibiotic is the important things that maybe help this issue worse and worse, and of course it can be a really a bad issue. That, for example, if we use antibiotic in viral infections or using them in livestock agriculture and something like that, it's we can development the problem. As I said, that it's a global health threat that lead to treatment failures, very long illnesses, and higher mortality rates. Golden note here is that Staphylococcus aureus can become increasingly and significantly real difficult to treat and cure because of this AMR and antibiotic resistance. In this study, we explored the genetic basis related These are related to genetic bases and somehow the mechanisms that govern its with bacterial population. In this research, we know that some sites, Google Scholar and Web of Science, we can use them. About keywords, it can be related to antibiotic resistance or some genetics, and we know that we just use some important and some lower validity, and our focus should be in near years, and the lower validity will exit from our study. About the results, this result shows hidden that genetic factors can underpin antibiotic resistant mechanisms, highlighting the intricate nature of adoption within bacterial population, and if they are related to each other, of course, they affect by their population. In addition, the impact of environmental factors on the development of resistance emerge essential issue. About conclusion, I can just say that at first, more research is needed to develop this this situation and this field of study, of course, at first I should say. But for conclusion, I just said that every field of study that related to genes are not just in the hand of scientists or in the hand of some researchers. It can be moral things and related to human rights, and of course the scientists can just, for example, use their knowledge to develop this field of study, but I hope to in the upcoming years have a better situation to use this field of knowledge help people and disorders. Thanks for your attention.
Can you give me an example what the genetic damage caused by resistance antibiotic?
What does I mean? Genetic what?
You mean the genetic damage, okay?
The area, the location of the damage.
Every genetic disorders, for example, that maybe like autism or something like that, can help with genetic editing and genes editing. For example, we can exchange the normal genes with abnormal genes with this field of issue with, for example, CRISPR, like something like CRISPR-Cas9 or something like that. And gene editing is really helpful for these disorders too, but I said that it's not really in the hand of researchers just. It's can be, but I hope it's better.
But first, do you think that the genetic change in human, okay, in human, genetic changes in human, has a connection with this resistance?
Yeah. You give me example of disease.
Yes.
Yeah, okay.
That was an example, okay. Just I have a question.
Yeah, of course.
As we know, this bacterial resistance is a global problem for using antibiotics.
Yeah, of course.
What do you think and what do you suggest for prevention of such occurrence of bacterial resistance, because it is increasing at a dangerous rate.
Yeah, of course. I want to add something that some working for combat this. situation. I mean, combat with AMR and prevention. This problem can, for example, be something like that, preventing the misuse of antibiotic, I said, and maybe a change or alternate the way of treatments. We can change or use to create some new antibiotics, because new antibiotics makes their mechanisms help to the genes to work in better way. I mean, work in a new way. That's, for example, combat with that previous AMR, and it can be helpful to it. And
so the most significant way and
of
available
course,
way is preventing
misuse.
misuse.
Yeah, it can be. And another one is devoted to prevent gene transfer between the bacterial species, because it's I said it's the most important issue or problem that really help to AMR. Of course. Yeah.
Thank you. Thank
You're
you very much.
welcome.